My dear ones, in the previous class, we have seen how does refraction take place in the glass prism and what is dispersion and how is rainbow formed. Am I right? Well, in today's session, we are going to see what is atmospheric refraction and scattering of light. What is refraction? You know very well. When light travels from one medium to the another medium, there is a change in its path or its speed. The phenomena is called refraction. The same phenomena take place in the atmosphere. Let us see it now. Here once, you could have seen during campfire, on the top of fire, we can see flickering of the flame. Have you noticed it? The next time when you are having campfire, please check it. Okay, why we can see that small flame on the top of the flame? Here, on the top of the flame, the air is very hot, but above that, the atmosphere is very cool. So, it leads to the phenomena refraction and changes its position. So, we can see the small, that is flickering of the flame. Since it is happening in the atmosphere, it is called atmospheric refraction. The same phenomena is used in large scale of twinkling of stars. And also, stars twinkle but planets do not. And what is the reason for this is due to atmospheric refraction. Okay, when we look at the star at night, you can see it flickers, fluctuates. Fluctuation, you know that is, isn't it? Due to imbalancing of power in the electricity, all the electrical appliances will fluctuate, is it? Why it happens or how it happens with the stars? Let us see it. Actually, we are seeing the stars, then little above than its actual position. Okay, let us see it. And also, why don't planets twinkle? Why do stars twinkle? It is due to the atmospheric refraction of sunlight. The sunlight, after entering the Earth's atmosphere, it undergoes refraction continuously before it reaches our eyes. The refractive index of the atmosphere keeps on changing. So, the atmosphere bends the light towards the normal. The apparent position of the star is slightly different from its actual position. So, we can see the star slightly higher than its actual position. This position of the star is not again stationary. It keeps on changing slightly because the physical condition of the Earth's atmosphere is also not stationary. In some place it will be hot, in some place it will be cool. So when light travels from denser medium to rarer, it will move away from the normal. It moves from rarer to denser. It moves towards the normal. It goes on changing. Since the stars are far away, it is like a point source of light. When light coming from the stars goes on varying slightly, the apparent position of the star fluctuates and the amount of star light entering the eyes flickers. That's why the star appears sometimes brighter and sometimes it is fainter. That's why we can see the star twinkles. Hope you understood. The reason is because the refractive index of the atmosphere is not same. It keeps on changing. So the light went towards the normal, move away from the normal. So the star twinkles and fluctuate. Next one is why planets do not twinkle. Here, first point, the planets are closer to the Earth, and here it is the collection of large number of point sources of light. The total variation of the light entering our eye from all the individual point sources will average out to 0. That's why it does not fluctuate. So planets do not twinkle. Hope you understood, dear ones. Here planets are very near for us, and before refraction takes place, it reaches our eyes. So it appears like without any fluctuation. Okay. And the next one, if we are looking into, during the sunrise and sunset, the apparent position is 2 minutes earlier and 2 minutes after during sunrise and sunset. Because the reason, first reason is due to atmospheric refraction, and the second reason is the size of the earth is not just like a circle, isn't it? It is in elliptical shape. The apparent flattening of the earth also, that is another reason. That's why it appears for us the sunrise is 2 minutes earlier and sunset is 2 minutes delayed one. Okay. Hope you understood. Planets do not twinkle, stars twinkle, and 2 minutes earlier sunrise and 2 minutes delayed sunset. The next topic is scattering of light. Light plays a spectacular phenomena with other objects in nature. There are many examples. Blue color of the sky during sunset and sunrise. The color of the sky is red color. At noon it is white color. Why? What is the reason? This is due to the scattering of light by fine particles present in the atmosphere. You have studied in class 9 what is Tyndall effect. Am I right? Yes. The scattering of light by the colloidal particles gives rise to Tyndall effect. Okay. For example, take sugar solution and some amount of starch solution. When light is passed through these two solutions, we can see the light in colloidal solution, but in the case of sugar solution, it is not visible. Why? What is the reason? In the case of true solution, the particles are very minute, but in collider the size of the particle is little more larger. So when light falls on the small size particles, it is getting scattered. For example, you just drop some beads into the mosaic floor or smooth floor, it will scatter here and there. Is it? Like that, scattering takes place due to the smallest particles present in the atmosphere. Air is a heterogeneous mixture, you know. It has many gases and water vapor and small dust particles, and many are there. Here, already we have discussed sunlight has 7 colors. Which one has more wavelength? Yes, red color, and shorter wavelength is violet color. So, violet color will be easily scattered by the smallest particles, and red color light will be scattered by the large size particles. And also, the scattering of light depends upon the size of the particles also. Dear ones, now we shall see and discuss what is the reasoning of blue color sky and red color sky during sunrise and sunset, and why sky appears black for the astronomers, and the phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. We can see it inside the forest filled with mist and road filled with mist and dust filled in the room. When light falls on the particles present in the atmosphere, it scatters away. You know very well, red light has longer wavelength and violet has shorter wavelength. Due to this property, the sky appears blue. The sky appears blue because the red color light has a wavelength about 1.8 greater than the blue color. When sunlight passes through the atmosphere, the fine particles in air scatter the blue color more strongly than red. So, the scattered blue light enters our eyes. But for the astronomers, since there is no atmosphere at such a height, no scattering takes place there. So, the sky appears black for the astronomers. And here once you could have noticed that in danger signal light are red in color, because the red is least scattered by fog or smoke, and also we can see the red color even from a longer distance. And also you could have seen the mist light is yellow color, and because we can see the object if it is in yellow color. The next one is due to reddening of the sky during sunrise and sunset. Near the horizon, light passes through thicker layer of air and larger distance to reach our eyes. So, most of the blue light and shorter wavelength are scattered away by the particles. Therefore, we receive longer wavelength of red color. So, the sky appears red color. But at noon, the sun appears white because little of the blue and violet colors are scattered. So, it appears white at noon. These phenomena are explained with the help of an activity. Take a tank filled with water and mix with sodium thiosulfate and add some amount of sulfuric acid. Keep 2 lenses sideways. When we look from one side, we can see the water appears blue color, but on the screen it appears red color. Here this is due to scattering of light because of sodium thiosulfate. It is a colloidal solution. So nearby when we see, it appears blue because blue color light is scattered away first. Then on the screen we can see red color because red light can pass through longer distance. That's why we can see red color on the screen. Dear ones, hope you understood the reason for the blue color sky, reddish appearance of sky during sunrise and sunset. At noon it is white color, and for the astronomers it is in black color.